Hey, algebra class. This is Mr. Johnston again. We're going to wrap up this first week of our pre-algebra review today by looking at adding and subtracting fractions, which really is the toughest thing we've looked at so far, and it's going to call on all of the other things we've done this week, from adding and subtracting integers, multiplying integers, to multiplying fractions. All that stuff's going to come into play here. So it is a little bit more challenging than the other things we have done so far. Adding and subtracting fractions also has a pretty strict set of rules. So in order to add or subtract, it doesn't really matter whether we're adding or subtracting for as far as the rules are concerned. We must have a common denominator first. If our fractions do not have the same denominator, that has to be addressed first. Okay, if they do, then we can skip down a couple of steps. But in order to get a common denominator, we're going to use the thing I call a tricky one to get that common denominator. Okay, once we've achieved that, either the problem started with common denominators or we did some work to get the common denominators, then we can add or subtract, depending on which the problem says. And when we add or subtract, we're only going to add or subtract those numerators, the top numbers together. Once we've done that, since we're dealing with fractions, we're going to have to reduce if it is possible. Okay, so I'm going to take a look at an example here. We'll just do one example this time. I think it will is going to cover everything that is in here. So, okay, how many cents is this? Pretty easy question. I mean, we could say, hey, look, coins. I know what those are worth, and would we say, and you probably know how much this is already, but we don't get to say one, two, three, four, five, six, seven. The seven cents, right? That's not how this works because these coins are not all worth the same amount, right? So I've got some quarters over here. Each of those has got a 25-cent value, and we've got some dimes over here, and those have a 10-cent value. So we don't get just, we can't just count, right? They have different values. Or we could say they have a different denomination. Quarters and dimes are different denominations of coin. Okay, so we could just add up the value of the cents, 25 plus 25 plus 25 plus 10 plus 10 plus 10 plus 10, and we come up with a total. Awesome, right? So $1.15, and that's totally not the point, right? I want to take something that's pretty easy for us to understand and use it to illustrate how to add fractions. So I'm going to change each of these into a fraction, not because I think this is going to be easier somehow. It's not, but because this will make sense for an illustration of why we need to do the things we have to do in order to add fractions, why we take the common denominators. Okay, so each quarter is 1/4 of a dollar, right? The denominator, this 4, tells us how many of these things are required to make one complete whole dollar. Okay, that's what this 4 is about. It takes 4 of them to make $1. Okay, and then there's 3 of them, so I got 1/4, 1/4, 1/4 3 times. The dimes, this is a little bit tricky here because they're worth 10 cents, and that is not where the 10 comes from. This denominator of a 10 comes from the fact that it takes 10 dimes to add up to one whole complete dollar. Okay, so each of these dimes gives us one of those 10 parts. And since there's 4 of them in the picture, we're going to have 1, 2, 3, 4. So that's going to be 4/10. Okay, I'm going to change this to a addition problem involving fractions. I'm going to do this twice. We'll hide this one for just a moment. Well, it's totally hidden. See, look, you can still see it. I know. All right, so I had the 3/4 from the left side, and I got the 4 dimes from the right-hand side. So I got 3/4 plus 4/10. Okay, you can't add that together yet because they have different denominators. Okay, so in order to move forward, I have to change the value of the denominator. But it would not be fair to just like randomly change numbers because then it's a totally different problem. So I can't actually change the value of the fraction, right? That's where the tricky one comes in. Okay, so I'm going to pull this over here. So we've got some workspace. I'm going to do this exact same problem twice, 2 different ways. And so I'm going to leave this other version over here for later. Okay, I don't need any of that stuff up there. I'm going to grab my pen. Okay, so I'm going to start the first time by using a common denominator of 100, which I think makes sense from the standpoint of there are 100 cents in a dollar, and we're dealing with coins, right? Adding up to, well, more than a dollar. But Okay, so there's 100 cents in a dollar, so I'm going to make that my denominator just for the reason that the 100 cents in a dollar. Okay, so we're going to look at this fraction over here on the left. The denominator is 4. I need to change it into 100. What do I multiply by 4 to get an answer of 100? Okay, so that's going to be 25. 4 times 25 gives me 100. So I'm going to multiply the denominator here by, oh, that did not write correctly. I'm going to multiply the denominator by 25. Okay, but I can't just multiply the denominator by 25, also have to multiply the numerator by that same amount. So I'm going to multiply by 25 up here also. So here's where the tricky one is. That is the tricky one right there. So check this out. If we look just at that one fraction, 25 over 25, it's also a division problem. 25 divided by 25. And anytime you divide a number by itself, that equals 1. Okay, so this red fraction really is 1, except in disguise. If I multiply 1 times anything, in this case by 3/4, I'm going to get 3/4, right? It will not change the value of that fraction. It's going to look different because I've multiplied both the numerators and the denominators. So they're going to be different numbers, but it will still have the value of 3/4. Okay, let's look at the other fraction. So I'm going to change my pen color. So I got 4/10. That also needs to have a different denominator. I'm going to change this to a denominator of 100. So I got to ask myself 10 as the current denominator. 10 times what will give me 100? So now I need to multiply by 10. I'm going to do it in blue because I want a different color. So I have to multiply the top by 10, the numerator, and also the denominator by 10. That gives me another one of these tricky ones. So that whole blue fraction, 10 divided by 10 is 1. And if I'm multiplying by 1, it does not change the value of the fraction. Okay, so now let's do these multiplications. So on the left-hand side, numerator times numerator, 25 times 3, that's 75. Denominators, 25 times 4, that's 100. Plus, and then let's do this part in blue. So I got the numerators, 4 times 10 is 40, and 10 times 10 is 100. And I need a little bit more space to finish this problem. Okay, let's see if the page will extend. Great. So now I have common denominators. The red fraction is a denominator of 100, blue fraction, denominator of 100. I can add these together. Once we get a common denominator, the only parts we add are the numerators on the top. Okay, so 75 plus 40 is 115. That doesn't look like blue to me. It's supposed to be writing in green, rather. It is blue. It's supposed to be green. 115. And the 100 is the denominator doesn't change, right? It still takes 100 cents to make a dollar. Whether I add the 75 cents and the 40 cents together doesn't change the fact that it takes 100 cents to make $1. Okay, so I got a common denominator, I added, hooray! But now I need to see if this is going to be possible to reduce. And I can see right now that it is definitely reducible. This one is pretty easy because the top number ends in a 5 in the ones place. There's a 5, and also in the denominator, the ones place is a 0. And I know an easy way to keep track of multiples of 5. They're always going to end in either a 0 or a 5. It's only possibilities. So I know that 5 will go into both of these numbers. Okay, so 5 goes into 100 how many times? I know that that's 20. Because I know 5 times 20 is 100. I'm not sure 115 divided by 5. I'd have to do some mental math, but it's a little bit easier here. I know that that's 15 more than 100. If 5 goes into 100 20 times, I need, in order to get 15 more, it's going to take 3 more 5s. So it's going to be 23. Or you could do it on a piece of scratch paper or a calculator. So 23 20th, 23 20ths. Right, there it is, the end. Okay, I'm going to separate my workspace. All right, let's do this a second time. This is going to be much faster. I'm going to save some steps by, instead of using a denominator of 100, I'm going to use the smallest possible common denominator. So I have to do a little bit of thinking ahead of time, so I get the smallest possible common denominator. So let's think, I've got a denominator of 4 and of 10. What's the smallest possible number that 4 would multiply into evenly and also 10 would multiply into evenly? It's probably going to be larger than either the 4 or the 10, but 20. 20 will work, right? 4 times 5 is 20, and 10 times 2 also gives me a denominator of 20. So let's do a denominator of 20. So I have to multiply both the top and the bottom by 5. And in the 4/10ths, in that fraction, I need to multiply by 2 so that I get my denominator of 20. Okay, so let's do the left-hand side. 5 times 3 is 15. 5 times 4 is 20. Plus, what? Plus, I'll just go on the top of that. Okay, and then 4 times 2 is 8. And 10 times 2 is 20. Okay, so I have common denominators. Now I can add the 15 and the 8 together. And 15 plus 8 is 23. Denominator doesn't change. That's still a 20. Blam. This one, since I don't have to reduce because I got the smallest possible common denominator, right? So it saves myself some work by doing a little bit of thinking ahead of time. Okay, good luck.